Hello, today we're going to learn how to make fractal terrains in Houdini and achieve a result like this. So let's jump into Houdini. This is where we left off last time in the height field lesson. So I will continue from here and make a fractal terrain. So just to reiterate, we made a custom height field. So let me just visualize this. And I'm going to disable this and show these steps from the beginning. So we started with the empty volumes and then created a height field like this that we then used an SDF to get this height field. And then we rounded out the edges and applied a noise function. And in this case, I want to make it a little bit more sharp. So I am going to remove this rounding, so we don't need that. And I'm going to change this noise function to something more interesting. Okay, so let's also go to frame 24 in the animation. Okay, we didn't add the animation last time. Okay. So let's delete this rounding so we have less to be confused about. And I will go into our volume VOP and into the snippet. And here we can see that we were using this noise function that already comes with a fractal feature. But this is not as nice as the fractal terrain we want to make today. So let's do our own fractal. So first of all, I'm just going to define a few parameters. So float, the first thing would be the amplitude. And let's say this is 1.0. And then we want a float frequency. Let's see. And let's set this to 1 as well. And then we want a float octaves. And that is how many octaves we have in our fractal. And let's start with 1 octave. And this is actually an integer, so this should be int octaves. And then we want to have the lacunarity, so float lacunarity. And this is the distance between octaves. And normally each octave is a factor 2 between each. So you would have 2.0 in the normal case. And finally, let's define a persistence. And this is how much of the previous octave is remaining for the next octave. So I will explain this more later. So set this to 0.5. So that means that each octave will only be half as big as the previous octave. And then in our code here, we have 3 octaves. So let's replace this with octaves. And we can set this to 3 so we have the same value. And let's change this to be the lacunarity. And finally, the persistence. And we have the amount. So I'm going to set here, let's see, the amplitude equal the amount. and I will set here this to be the amplitude. Amplitude. And let's see what we get. Amount. So this should work. So just click on something so it resets. Okay. So this is the same result as we had before. And we are using this built-in noise function. And also let's change the frequency to be 1 divided by 1000. And this would then be P times frequency. Okay, so now we want to create our own fractal. So to do this, we are not going to use a fractal noise, but a normal noise, and loop through each octave. And for this, we are going to need a for loop. So type for, and then int I for index equals 0, and then semicolon. And the first is the initialization, so I will start as 0. And then the next thing is a comparison, so while I is less than octaves. And this means this loop will continue as long as this index is less than the total number of octaves. And we will increase the index each iteration. You can also think of I as iteration. And then create a block using these curly braces. Okay, so now let's move our noise inside here. So let's take this function and move it up here. And let's set the offset to be 0. And then let's move this inside the loop. And let's say that the offset plus equal. So we'll add this noise to the offset in each iteration. And instead of the fractal noise, we are going to use the normal noise. So I will remove these last parameters. And let's see, we don't get really any result yet. Okay, we still have to update the amplitude and the frequency for each octave. So let's multiply the amplitude by the persistence. So the amplitude times equal the persistence. And the same with the frequency. The frequency times equal the lacunarity. So the lacunarity is the change in frequency between octaves, and the persistence is the change in amplitude. So this will double the frequency, and this will halve the amplitude. And now we get something that should be the same if we had trusted what the built-in function was supposed to do, but it's not the same. But it doesn't matter because we're going to make our own noise here. So for this I want to use a curl noise. So curl X noise. And the X means that it is based on a on a simplex noise. And let's look at this result. Okay, so we want the amount. Okay, now let's go to frame. Let's check the value of the amount. So let's go up and look at the volume VOP, and the amount is 20. So let's say set this to 50. So now we have a little bigger effect. And perhaps even 100. I think that may, well, let's use this for now. Okay. And then go back to inside the volume VOP and to the snippet, and let's see. Maybe we want to have a little higher frequencies. Let's increase the frequency. And that's too much. Okay. Let's say the 500. Okay. And let's go back to only one octave. So this is the first iteration. And then it will add one more octave. So 2 octaves. And 3 octaves. And 4 octaves. And 5 octaves. And 6 octaves. And let's continue as long as we see a change. So let's go to 7. And each time you get more and more small details. And the red color is starting to get a bit distracting. So let's say set the mask to 0. Okay, and let's see if we add one more octave, so 8 octaves. And you could see a tiny change, and let's try 9. And this is no change, so 8 is enough to have full detail. And I think let's go up and go to the amount. So we can go down to, let's say, 50. And we can also go back to the signed distance field and change the distance to add the height. So let's say 400 meters. So now we have a 400 meters high mountain. And this is still not, I think, not strong enough. So let's go back to the volume VOP and set this back to 100. Okay, so this is more or less what we had in the example. And let's see, maybe a little less 80. And now you could animate this to have no noise applied, or you could have more applied like this. And if you animate the amount of the warp and the height of the signed distance field max value, then you will get this effect that we see here. I hope this was helpful, and see you next time. Over and out.